Hello, today's math lesson is 1-3, and we are working on finding absolute values, understanding what that word absolute value means, and also finding magnitudes to compare real world situations. So if you have not already done the Spark Your Learning page, make sure you go and take care of that first, and then come back and we will get started. So this table here shows low temperatures in Nome, Alaska for 5 days in December. We want to find the distance from zero to get to each of these temperatures. So I could model this problem, and whenever I'm talking about positive and negative numbers, I always like to use a number line. I can also think of it as a thermometer. So I'm going to go ahead and draw my number line here and get 0 on there. So my mouse is not quite finishing my numbers here. So I know on December 18th, it was -10. And if we remember from our previous lessons, the negatives are always going to be on the bottom and the positives are going to be on the top. I'm looking at -10 here, so I'm going to go ahead and place it here. -15, I know if I'm going down here, it'd be -1, 2, 3, all the way to 10. Oh, I forgot my negative sign. And if I get to -10 is -15. And then the next day is -16. So if I keep on going down, I'm going to get to -16 here. And then 8 is going to go up to the top. And then 3 would be 0, 1, 2, 3. Oh man, my mouse is having a really hard time today, you guys. 3, oh my goodness. And not an S, an 8. Wow. Okay, thanks for being patient with my crazy mouse. So now I need to come. Okay, so I have modeled each of these temperatures, and now I need to go back and double check what the problem is asking me to do. So I need to find the distance from 0 to each number. And when we're talking about distances, we're always going to write those as positive numbers. So we're saying it's just how far away, whether it's positive or negative, we're just saying it takes this many units to get to 0. So if I need to go from 0 to 8, I know that's going to take 8 units. If I need to go from 0 to 3, I'm going to count 3 units. If I need to go from 0 to -10, even though it's on the negative side of that number line, its distance to 0 is still 10 units. And if I need to get from 0 to -15, even though it's a negative number, its distance to 0 is still just 15 units. And to get from 0 to 16, same thing, even though it's negative, my answer is just going to be 16 units. I'm saying this is how many places I have to count, whether it's positive or negative. How many places do you have to count from 0 to get to that number? So if I were finding the distance from 0 to each number, I would count the units between 0 and the number. The answer will always be positive when talking about distance. Okay, now it wants us to match each temperature with its distance from 0. The temperatures are here on the left and the distances from 0 are on the right. So I have -10. It's going to be from 0 to 10. It's going to take 10 units to get there. Notice all of these distances are all positive. If I need to go from 0 to 15, that will take 15 units. From -16 to 0, it's going to take 16 units. From -8 to 0 is going to take 8 units. And from 3 to 0 is going to take 3 units there. Hey, your final part for your spark was to name a real world situation where you might need to find the distance between 2 points. A time that I can think of is if you have two friends walking home from school. So school would be like 0. The distance to their houses would be a positive number, even if the friends lived in different directions. So if I had my school here and one friend lived here and one friend lived here, their distance is still going to be positive. One doesn't live in a negative distance from the school, and I could tell how many units away they both lived from the school. Okay, so let's go ahead and start on our tasks for today. So hop on Ed with me and toggle over to your next page, task 1. So we are going to work on applying this absolute value. This is what we've been talking about. We just haven't quite given it a mathematical name yet. So we've got this picture here, and it is showing the elevation of 4 fish in a lake. You remember, elevations are telling distance from sea level. The elevation of the top of the lifeguard stand is 6 feet. We can see the 4 different fish. So the top of the water and the top of the sand is sea level 0. So the first thing we're going to do is drop all of these numbers onto our number line. So I can see here is 0, +5, +6. Make sure your positives are on the right, your negatives are on the left. And if I go this way, here I get -1. Make sure it has my negative in front of it here. So go ahead and pause the video and see if you can finish placing those last few fish on the number line there. Okay, so once you have your fish there, now we are going to match the elevation with the distance from 0. And remember, distances are always going to be a positive number. And I can see some of these answers down here have negatives on them. So it's going to try and trick you. So we'll see if you've been listening. So to get from 0 to sea level to 6 feet up would take me 6 feet. We're not doing opposites. We are just telling how far away it is from 0. Okay, to get from 0 to -1, I had to move 1 unit. Doesn't matter if it's negative or positive, I moved 1 unit. So I put my 1 here. So go ahead and pause the video and see if you can finish telling me the distances for these other fish from sea level. So what we've been doing is we've been talking about the absolute value. We just haven't given it that name yet. So when you are telling the distance from 0, that is called the absolute value. Its value is always positive, and you just tell how many units away from 0 it is. You show it by these 2 parallel lines here. So you can see down here, we're talking about this number -3. So here's -3 represented. And these lines on either side of the -3 are asking you to find the absolute value. So the absolute value of -3 is 1, 2, 3 units from 0. So our answer would be written as just a plain old 3. So let's try some of these out here. So the distance from a number to 0 on the number line is our absolute value. We're going to be using this number line to help solve these. So the absolute value of -1. So if we're here at -1, how many times do we have to move to get to 0? That would just be 1 unit. So here, I just type in 1. To get from the lifeguard, who was 6, all the way over would be 1, 2, 3, 4, 5, 6 units. So again, absolute value is always positive. So pause the video and see if you can finish filling out the absolute values of how far it takes to get from -3 to 0, from -10 to 0, and how many places from -6 to 0. Okay, this next part, instead of having the words written out, absolute value, it's showing us that absolute value symbol. We are still doing the same thing, absolute value of -1. So to go from -1 to 0 takes 1 unit. Type that in there. And I'll pick a different one to do. I'm going to go down to this bottom one. If I'm at -6, so I'd be all the way over here, -6, and I need to get to 0. It takes me 1, 2, 3, 4, 5, 6 places. Even though it started at -6, it takes me 6 moves to get back to 0. And that distance is always positive. So pause the video and go ahead and finish this C part here. A for D, it says negative numbers are less than positive numbers. So we know that to be true. They're below and they're to the left on number lines. They are smaller than positive numbers. Does this mean that absolute value of a negative number must always be less than the absolute value of a positive number? So let's think about an example here. So if I have the numbers, let's say -1 and 7, I know that 7 is bigger than -1. If I compare their absolute values, it takes me 1 place to get from -1 to 0, and it takes me 7 places to get from 7 to -1. 7 is still bigger. Let's try another example. So in that case, the positive number is bigger both times. So let's say this time, let's switch those numbers around and let's have -7 and 1. So -7 is smaller than 1. If I have $1 and you have -7, I've got more money than you. So let's think about their absolute values though. How it takes 1 jump to get from 1 to 0. So that has an absolute value of 1. I'm at -7. It's going to take me 7 places to get to 0. So that absolute value is 7. So that absolute value of the -7 was actually larger than the absolute value of the 1. So if I'm only comparing the values, 1 is bigger. But if I'm comparing their absolute values, the absolute value of -7 is larger. Let's answer this question together. I know that can be a little tricky to think about. So let's jump down to this example. -7, I know -7 is less than 3. So that sentence reads true, that inequality. But the absolute value of -7 takes from 7 places to get to 0. 7 compared to just 3. When we talk about the absolute value, sometimes this sign can flip around. Not always, but sometimes. So the absolute value of a negative number can be bigger once we look at the absolute value of the positive number. So the value is still smaller, but the absolute value, how many places it is to 0, can change sometimes. Hey, so I've talked about this a lot of times if you've been listening. If you're not sure, you can go back and listen to some of this video. So can the absolute value of a number be negative? So go back and listen if you're not sure and give me your answer there. Hey, one more task today is task 2. And that's a creepy little bug kind of jumped out at me. Okay, so the magnitude of a number is its size or the amount without considering whether it's positive or negative. That's what we've been talking about. So the magnitude of a number is the same thing as its absolute value. So magnitude, absolute value, they mean the same thing here. So let's look at this here. So some insects produce a chemical that prevents the water in their bodies from freezing and it helps them survive extreme cold. An insect's supercooling point is the lowest temperature at which it can survive. So I'm thinking temperature, I'm thinking my number line up and down. So lower the temperature can go. So some of these can survive very cold temperatures. So this table shows the supercooling points of these insects here. So the first thing we want to do is drop these on here. So I can see 0 over here on the right. We don't have any positive supercooling points. So if I'm coming here, so here's 20, here's, looks like we're counting by 10, -10, -20, -30. So I'm looking for a number between -30 and -40. Oh, here we go. So I'm going to drop that there. I can see this one is about on the -70. So why don't you go ahead and pause this video and see if you can finish those 3 there. So now we're going to tell the magnitude. So remember, magnitude is the same as absolute value, and absolute values are always positive. So we've got -70. So to get from -70 all the way to 0, so to get from -70 all the way to 0, we've got to go 70 units. And it doesn't matter that this was negative. We're just talking about the distance here. Distances are always positive. So go ahead and see if you can finish B and pause the video. Okay, part C, we're going to complete these sentences. So we've got our absolute value symbols, and we're going to show the magnitude of these. So to get from -70 to 70 takes 70 units. So go ahead and pause the video and see if you can finish part C. And part D, we're going to write an inequality. So remember, an inequality is going to use the comparing symbols. You can find these comparing symbols right next to the letter M on your keyboard. So right by monkey, M, you can see the less than and the greater than sign. So I'm going to start with -70, and we're going to compare that to -35. So I need to think about my number line. And I'm trying to show either way, which one is larger or which one is smaller. So if I'm at 0 and I need to think, so I'm going to scroll and see if I can find myself a number line here. So this can help me up here on part A. So if we remember, the farther to the left, the colder it is, the smaller the number. So we're comparing 35 and 70. So it looks like 70, is a lot lower than 35. So -70 is less than -35 is how you would write that statement there. Part E says which best explains which supercooling point is closest to 0 on the number line. So if we come up here, and here's our supercooling points, you can find your answer from part A. The closest one to 0 is right here. So go ahead and pause the video and pick the correct answer for part E and answer that. And then part F, our last part today, asks us to choose which insect has the lowest supercooling points. I'm going to come back to my graph here, my number line, and I'm looking for the lowest number. That means the one that is most to the left. So all the way over here, we've got this -70. So now I want to come and read my chart and find the one that matches up to -70 and get my answer put in for F. Okay, so that is our lesson for today. So make sure you go back into your Ed tab and mark that you have completed this. And then you need to do the check for understanding. And then you go back to Canvas and let me know how you think you did today. So, great work, guys.